Okay, so you guys should have had your entrance slip. Everyone should be done with that. Today is September 12th, so make sure that you put date today. It's a little small for a pen. So today is September 12th. We're working on section 1.4, it's tables and slope. And the objective is that we want to understand the relationship between difference tables and slope. Okay. All right, so we've seen this table as kind of a table before. These are just all the different ways that you can think about your input. So it could be X or a letter. Frequently we've used N here. It could be your input. F of X, remember that means your output, it means your Y. So all of these are synonyms for your output. And then again, different ways that you can think of your rate of change, your delta, your slope. This is just here. So if we think about yesterday, we had a difference table similar to this where we had to fill out these missing pieces right here. And if we know that a table has constant differences, it means that every delta on the table is going to be the same. So if we think about it, if we look at this right here as kind of our difference table within a difference table. Okay, when we create a difference table, remember that we don't ever use that piece right there. Okay? So think about on a number line, how many spaces are there between 18 and -2? There should be 20. So we have to split that up between 1, 2, 3, 4 deltas. So 20 divided by 4 is 5, which means every delta in here is going to be 5. This one, there shouldn't be anything there because there's nothing down below here to subtract this one from to get a delta. But all of these deltas in here should be 5. So the rate of change is constant. So in order to find out what goes in each one of these spots here, we just take this here, this output, add it to our delta, and we get the next output. So -2 plus 5 is 3. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. And 18 plus 5 is 23. So we've seen a couple of difference tables like that already. We had one on the assignment from Friday, and then we had one on the assignment from yesterday. You should have recognized that there was one like that on your entrance ticket from today as well. So basically, again, what I'm asking you to do for this one, okay, an input-output table has constant differences. When the input is 2, the output is 9. When the input is 7, the output is 6. Find the common difference. So what I'm asking you to do is to create an input-output, or actually a difference table for this one, and then figure out what your delta is. Common difference, constant difference, those mean that your delta is going to be the same every single time. So here's what your table should look like to start. So if you guys want to pause it for a little bit and take a couple of minutes to work on the table, and then when you guys are pretty well finished, then you can unpause it and we'll continue. Okay, so let's see if we can figure out what the common difference is. So we're going to start down here with this -6, okay? And then we're going to subtract out. So on a difference table, remember, you work your way. Remember that in a difference table, you work your way from the bottom to the top by subtracting. So if these are the two pieces that we know, we're going to take -6 minus 9. And then we want to figure out how many deltas there are in between. So what we're going to do is we're going to come over here now to this other side, and we're going to take 7 and this one. We're going to use the same inputs that are right next to our outputs, minus 2, okay? So what you notice is if you think about yesterday when we were talking about it, we were saying, okay, well, how many deltas are there between this 6 right here and this 9 right here? And we just counted, right? 1, 2, 3, 4, 5. Okay, well, where does that 5 come from? It comes from the input next to the negative 6 and the input next to the 9. So if we take negative 6 minus 9, we get negative 15. And if we subtract 7 minus 2, we get 5. Well, we can surely reduce that. Negative 15 divided by 5, we all know, is just negative 3. This means that our delta, our common difference, is going to be negative 3 every single time. Okay? You should recognize this formula right here. Okay? Another name for the output that we just talked about is y, and the input that we just talked about is x. And if you remember all the way back from Algebra 2, y2 minus y1 over x2 minus x1 gives us the formula for slope. And we know, if we go back a page, slope and delta are the same thing. So here would be my y2, here would be the y1, here's the x2, and the x1. Okay? So again, an input-output table has a constant difference. The input negative 1 has output negative 2, and the input of 9 has an output of 38. Find the common difference and draw a table with inputs from negative 1 to 9. So again, I'm going to give you guys a couple of minutes to work on this, see if you guys can figure it out. Go ahead and pause the video to take a little time, and then when you come back, we'll work the table together. Okay, so we're going to start with the inputs. And then we have our outputs, and then we have our delta column. So we have negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? We know that the input of negative 1 has an output of negative 2, and we know that the input of 9 has an output of 38. Okay? So just like we did last time, we're going to start with our outputs. So 38. I'm going to start with this one first. So 38. On this one, we have to be careful. When we subtract it, we have to make sure that we're subtracting a negative 2. And then we're going to come over here to the input. We're going to use the input that matches this output and the input that matches this output. So these are the two inputs that we're using. Okay, so we're going to start with the bottom one because that's the one we started with over here. So if we start with this one first, we have to start with this one first. If we start with this one first, we have to start with this one first. And again, we have to be really careful when we subtract this one up here. We have to make sure that we're subtracting a negative 1. Okay? So if we take 38 minus a negative 2, we all know that these turn into pluses. And the same thing with this right here. Okay, sorry. So you have 38 plus 2, which is 40. And you have 9 plus 1, which is 10. And then make sure that you reduce that, so 40 divided by 10 is 4. So that means that each delta along here is going to be 4. And mine are going to be really off, but you guys can fill that in on your own table. And then in order to figure out what your outputs are now, all you have to do is just take negative 2 plus 4, 2 plus 4, 6 plus 4, etc., and you should end up down at 38 here. Okay, so just remember, these are all the different ways that you can think about slope. So slope is rise over run, and remember that rise is your y's, okay? It's the up and down part of your graph, and run is your x's. It's the left and right part of your graph. This symbol here is your delta, and we say this change in y over change in x. So if we think back to this one, how is your y changing? How is your x changing? Because remember, this is the same thing as x, this is the same thing as y. Okay? This is kind of the formula that we've been talking about today, y2 minus y1 over x2 minus x1. And it's the same thing as change in your output over change in your input. So it doesn't matter what points you have along here, you can always use those to figure out what your delta is, okay? So basically what this means is that all of this gives you what your common difference is. So slope is rise over run, it's change in y over change in x, it's y2 minus y1 over x2 minus x1, it's the change in input over change in output over change of input. They're all the same thing as your common difference. Okay, your assignment today is page 24, 1 through 9, 12 through 15, 18, and 19. You have the rest of the class period to work on it. If you have questions, send me an email and I will try to help you as best I can.